Hello, welcome to this webinar. Thank you so much for being here. Today in this webinar, we're going to be speaking with Jan Ritter, Chief Technology Officer at SEEDFORWARD, and Pedro Liñán, who is Business Development Manager for Europe at Biome Makers. Today, let me present the agenda that we're going to have for today. Sorry. I think you can see it now. So first of all, Jan is going to speak about SEEDFORWARD, what they do right now, and what type of product they are developing. Then Pedro is going to speak about Biome Makers. Then both of them will have a discussion about Does Soil Health Matter? And then we will explain about this project, awesome project, another one with a BeCrop trial project. And at the end, we will have like 10 minutes for question and answer. So you can put all your questions on the chat. And also on the question section. So Jan, if you would like to start, the floor is yours.
Hello everybody, thank you Juan for the introduction. My name is Jan. I'm one of the founders of SEEDFORWARD. I'm responsible for all R&D activities here in our company, and our sole focus are seed treatments, mainly bio-based. We're still a young company, founded in 2018. We're now around 20 people here, have everything under one roof, lab, the production, all the offices. We have strong focus on R&D, a lot of field trials, and so on. I mean, to develop such a product, it takes us internally around 3 years, and then followed by trials with our customers. We have a lot of cooperations with renowned breeders, and for the sowing next spring, we are on nearly 300,000 hectares, mainly in Germany, but also in other EU countries. Next slide. Our technology, the SeedFX technology, it's patented. It's like a basic formulation which we then adapt to the target crop. Right now, we are commercial on corn, cereals, and legumes, and from next year on also on oilseed rape, which will be the topic today. It's quite a complex formulation. In each product, we have more than 20 active ingredients where we're using synergistic effects. And as I mentioned before, it's always adapted to the target crop because every crop has a different demand and reacts differently on biostimulants. Maybe that in a very brief description. We don't have that much time today.
Well, thank you very much for the introduction, Jan. I'm Pedro Liñán. I'm from Biome Makers, and what we do at Biome Makers is that we are focused, as you see in the slide, to decode soil biology. We are a company founded 9 years ago already in California, and with headquarters in California and in Spain, also for Europe. And we are specialized in understanding what happens in the soil, what happens in the soil at microbial level. We as a company are focused on working with a topic which is now really important in agriculture, which is how to bring sustainability in the terms of understanding soil and working with the soil. So we are really mission driven as a company. And in the last years, we have been making impact in different regions of the world, working with different types of farmers, industries, companies, corporations, universities, helping them to understand how agriculture and soil are connected through microbiology. As you can see in the next slide, we have been working with more than 200 collaborations in the industry. We have helped farmers to reduce the use of fertilizers and agrochemicals too, in up to 20%. And we have also been training people to understand and help them to use BeCrop Technology to understand soil and help farmers. We have trained more than 1,500 BeCrop advisors in the world. And our reach, in the next slide, we can see that we work right now in more than 50 countries, and we work also with more than 170 crops right now. Our values based on the database of the microbes that we have, which have been taken in more than 50 countries and with more than 170 crops. And we work with partners everywhere in the world, here in Germany, for example, with SEEDFORWARD, and we have also distributors in the South and North America and also in Europe. The base of what we are doing at Biome Makers is that we are understanding soil in the term of the functionality. When we understand soil until now, until some years ago, the understanding of soil was all times that it has three parts: physical, chemical, and also biological. But biological was too complex to evaluate, and we have been working for decades with physical and chemical analysis, which gives a lot of information, but it's not enough because we know that we have a third dimension. So understanding the third dimension, it's not so easy as saying, okay, which microorganism do we have? This is an information that it's interesting, but it's maybe not enough. And that's why in these years, we have developed tools to understand from the microorganisms that we have, from who is in the soil to what are they doing in the soil. So understanding this information, this bio information, and converting that into what are the functions of those microbes. You can have a population, for example, we are now in Germany. You could have a population that has different names, different colors, different everything, different opinions. But what is important in terms of the soil is what are they doing, and what are they doing? It's their job. You can have many technicians, many professors, many of every different function, and you need a good mix of the different jobs or functions in the soil. And that's what we help to understand. We help to understand what is the function of the population of microorganisms in the soil. To say, you need to improve those ones, or you need to improve that ones in terms of agriculture. And in the terms of working with companies like SEEDFORWARD here, we help to understand what their products do. And therefore they can approach farmers with a clearer perspective, because if a farmer needs to improve a certain value, and SEEDFORWARD has a product that it's helping to improve the resistance of the plant because the farmer has a soil that needs more resistance for the plant, it's a perfect match by understanding what's happening in the soil. And that's how we work. In the next slide, you can see that we have different products: BeCrop Test, BeCrop Trials, BeCrop Trade. Every product focusing different perspectives. The trials that we are going to discuss today, the test for the farmers, and the rate for understanding the sustainability of farming systems. So in the next slide, you can see that what we are going to discuss today is focused on the application of BeCrop Trials for understanding the effects of a product, where we evaluate the changes in the disease impact, in the nutrition impact of the product, and also evaluating that across different locations and understanding what's happening, like what we are going to explain today. But I'm not going to speak so much about the BeCrop trial right now, because I want Jan to explain us what's in the next slides later, what is the project that we had here. But before that, we want to focus a little bit more on talking about soil health, and because we think that it's a quite important topic. Therefore, I wanted to ask you, Jan, what do you think it's important, soil health, in terms of sustainable agriculture? More than sustainable agriculture, let's say the future of agriculture.
Yeah. I mean, soil health at the end of the day, or in general, soil, it's the foundation of life. It's the foundation for every farmer. It's the most important thing at the end of the day, even though it's below our feet. And I think in the past it was too much neglected. You know, also looking at crops, everybody is just looking at the above biomass, but nearly half of the plant is below ground. So it's really cool that there are companies now like Biome Makers that we all gain more in-depth insights into this complex system, and everything starts down there. So, you know, a healthy soil will be important for good nutrient availability and so on. it's super important for plant health. So my theory is, if the soil would be in perfect order, most probably we would nearly need no pesticides. And
that would be amazing.
And that should be the aim. And I mean, there are so many ways to have an impact on soil health, looking at crop rotations and so on. And sure, also like the small screws, like return with a seed treatment can have an impact. But at the end of the day, it's crucial. It's the most crucial thing to have a healthy soil. I think we could talk now a few hours about the importance and what it really means, but in general, it's important for water retention, nutrient uptake, and plant health. So
yes,
for everything.
We are starting to discover what's happening in the soil and what's important of soil, because in agriculture we have advanced a lot in the last 100 years, of course, but soil was a topic which was a little bit misunderstood, let's say, and we are seeing that it has a lot of potential, and that's amazing.
At the same time, we have quite some challenges looking at soil health, and my question would be, how is Biome Makers addressing challenges looking at soil health, soil degradation, and how can your products help?
Well, that's a good question. I would say that in terms of soil degradation, we have two strong challenges. First of all would be the fact that soil degradation is something that happens in a really long term. So to understand at farmer level, it's really difficult to see that the soil that your father had in the farm was better than what you could have now. So it doesn't mean that every farmer has degraded soil, but it's really difficult to take into account if it has degraded or not. And also recovering that soil, it's not something that you can do in 24 hours or even in 2 or 3 years. You need time to improve soil. So understanding that soil is degrading, it's a long-term process, which is even, let's say, bigger than human scale, we could say. And improving that, it's not bigger than human scale, but takes time and a lot of patience, and also a lot of measurements. We have seen already many times. We see that in social media and LinkedIn. You can see that those images when you have soils with plants with no plants per soil, and how it comes the water with different colors completely. That's soil degradation. So there's many parts of soil degradation: chemical, physical, but also biological. And biological is the one that we didn't know until 10 years ago how to evaluate that. And also there's another challenge here, and it's the abuse of tools. In agriculture, we have fantastic tools. We have different herbicides, fungicides, machinery, fertilizers, the possibility to make big areas with the same crop and manage it properly with more easier techniques and making it more optimized in terms of production. But it's quite easy to get too far away with the use of a certain tool and get too easily into using less tools that are not creating a soil environment that is healthy, let's say. And that's a quite important topic. Those two, let's say, from our perspective, from my perspective, two challenges that we have to tackle. But on the other side, and that's where Biome Makers is working, right now we are under climate change. We see that in this climate change, crops, crop timings, crop pests, even the crops that are in certain regions are needing to adapt, or the farming systems need to adapt. And for understanding how to adapt to different crops or different treatments or different conditions, we can get into something that it's amazing. We were talking that soil is an ally that can help you to have more nutrients or more resistance to certain diseases. So soil is there and has resources for helping the plant to grow. And understanding, I come back to what we do at Biome Makers, understanding that soil and how we can improve it, we can adapt to climate change. So I see here a really good opportunity in what we are doing and comparing with the challenges that we have. So that's amazing. I think that's really cool.
So you say your tool could help to understand the biology, and then I would know how to build up the soil again.
Exactly. For example, imagine a farmer that has been using a certain methods for many years, and he sees, we can evaluate and say, like a doctor, when you go to the doctor and he says you have low levels on that, then you need to diversify a little bit your diet and put a little bit of extra of what you're missing to have a balanced level of healthy in your body. The same thing with agriculture.
Yeah.
Of course, biology is not the only thing, but it's a quite representative thing of the health. As one of my friends said, you can only evaluate health on something that it's alive.
Yes.
So yeah, that's quite important.
Yeah.
On the other hand, what do you think that are the most promising techniques in the future of agriculture? Let's say in the coming 10 years, especially for at soil level with sustainable agriculture. How is it going? What are the most interesting things, do you think?
I guess you're part of one of the most interesting things. If we would really understand all the connections down there, that would be amazing. You know, then we could really time-wise say, so now you need this type of nitrogen fertilizer because the microbial dynamic in the next days will be perfect to mineralize or whatever, you know, to really understand all the interconnections and so on. I mean, it's highly complex. You know it better than I do, I guess. That would be amazing. I guess also looking at artificial intelligence, we can get closer. I mean, what do we know right now? My last figure was around 5% of the soil microbes are identified. So it's still a black box somehow.
Completely.
And I think we should crack it, and then we could design products which can make soils healthier. And another big topic for me, I mean, I'm more into biotech, you know, so endophytes. You know, I guess we're also still just on how to say in English, on the tip of the iceberg.
Yes.
I mean, there are theories now, or maybe also some first studies showing that systemic biological plant protection is possible. You know, I think there's a new dimension to discover somehow. I guess those 2 points are, in my view, at least a big part of the future, or should be. I'm not the technical guy or the digital guy, you know, into these things. Sure, digitalization will also play an important role, I guess, also looking at precision agriculture. But if we don't understand soil, I mean, then it's again, we can use tools blind, and we should understand.
We have there a great opportunity of understanding, because always when we look at microbes and our perspective a lot, you see that microbes have certain functions for nutrition, for plant protection, for plant growth, for plant stress adaptation, and for, of course, maybe they are not being able to give all the needs for the plant, maybe, but if we can reduce the needs of the plant by having a healthy soil and a soil that is adapted to the crops that we are growing, that's a really big step into the future of agriculture. Of course, we need a lot of information for that. Yeah. One of the questions that you asked me this morning was about what are we doing right now? What are we planning to do on launching in the future?
Yes.
Yeah, I didn't ask you before, but we are at Biomakers. We are focusing a lot on creating a bigger scale of understanding. So to be able to even modelize, if we test products with you, if we test a product in several locations, to be able to modelize and with AI determine how is it going to work in southern Spain.
Yeah.
So not needing to analyze the product everywhere in the world, but to have an image that allows us to predict how is it going to affect. If in southern France it's going to affect better than in western France. That's already a point that it's really interesting. And we are working a lot now about understanding which farming techniques are better for increasing soil health. So for different crops, for different regions, which farming techniques, which products, which techniques for tillage or not tillage, cover crops. So all this information that provides, let's say, manuals of understanding how to improve soil health and healthy farming systems. That's those are big projects. But we are really into it.
It's a lot of data, I'm sure, but I mean that's the way to go.
Exactly.
I'm more than sure about this.
Okay, maybe we can pass to present what we have done together, the project that you were evaluating. We are going to present now the analysis and the project evaluation that we did about one of SEEDForward's project, but I let you continue and explain us what we did here.
I think I mentioned it already. Today it's all about our prototype for oilseed rape, canola gourd, and I mean we did now 3 years of trials. I guess we do 1 more year. Nevertheless, we defined based on our data, we know a bit what our product does, and I mean that's what we wanted to confirm with your approach. So it's all about crop establishment, field emergence especially, but also then directly better root and shoot development, so better youth development. Then the big topic we talked about nutrient efficiency, which is mainly based on an improved root system. But yeah, we wanted to see if there is more what our product does, and at the end of the day, the most important, crop vitality. We saw that now over 3 years, so that are our main claims. And at the end of the day, it's about yield stability. And
what are the main risks for this? What are the main risks for this crop right now? Why? Because your product is focused. This product that we tested is focused exactly on this crop. What are the main risks, and why are you addressing those risks?
I mean, for all crops, you know, crop establishment is crucial. It's all about to have a good start. And I mean, looking at climate change, the root system is for all crops important, especially the fine roots. I mean, they create the access to nutrients and water. At the end of the day, it's more important than the root length. So that also counts for oilseed rape. So looking especially at oilseed rape, I guess the biggest challenges are diseases, pests. I mean, it's not a biocontrol product. It's more about pushing the plant, giving a good start. And you know, for some diseases or pests, you can also already help when you grow fast enough out of the critical phase.
That's what I wanted to say. When you have a stronger plant, it's not all about fighting the diseases, but being strong enough that the diseases do not affect the pathogens. Okay. Sorry for interrupting.
No, good. Maybe next slide. That are our figures so far. We have now 30 plot trials. For our other commercial products, we have more. So we are pushing this year. We have a lot of trials again. And here it's just a summary of everything. Like I said, we have improved germination. So it depends always on the environmental conditions. In many cases, we see improved field emergence compared to the normal standard chemical seed treatment. Then what I mentioned, improved shoot and especially root mass, and especially the fine root content. We see an increase in average around 20%, higher leaf area index, healthier, stronger crop towards winter.
Okay, that's a clear benefit.
Yeah. You know, in Central Europe, it's mainly a winter crop. So in other parts of the world, there's also spring canola or oilseed rape, but
because just to explain it to our audience, where is it? What's the cycle of this crop? In this case, it's when is it seeded on the ground?
It depends on where you are, from end of August to mid of September. Mid of September for some areas, it's already late sowing. And then harvest, depending on environmental conditions, June, July. And then already, you know, the seeding starts, so the time in between is quite short. Yeah.
So the first months are critical to develop the crop before the winter comes.
Yeah, exactly. Yeah, exactly. And that's our main focus. Nevertheless, we see also still effects in spring, because, you know, when you have a better root system, you will also find that after winter, and it helps the crop again to get started again.
Okay, perfect. So these are the results that you have seen when you have evaluated the crop, the plant, the aerial, the root systems. Okay.
Yeah. And in some cases, sure, not in every trial, but we also see a slight yield increase. But, you know, based on a bio-based seed treatment, it would be wrong to promise a yield increase. It's more like a additional insurance.
Yeah, that's really important.
And over the trials, I mean, we have 30 trials in small plots, but we have a lot of demo trials as well on farmer level. So, you know, big scale trials, and all in all, we could say we see a yield stabilization.
Okay. And what was your the trial that we are going to see? It's in the next slide. It's a trial based on evaluating the effect, as the hypothesis says here, to evaluate the effect on the functionality of soil microbiome. What was, so your product, it's not only helping the plant,
Exactly.
but you developed it with the expectation that it develops also the environment of the plant.
Yeah. As I said, we have more than 20 active ingredients, and around 1/3 we don't put it in there to help the plant. The aim was to assist the soil microbiome, and that's why we started to work together with you to prove that.
Okay.
You know, if it really makes sense what we throw in the bottle, but sure, that's the aim, because, you know, everything starts down there, and it would be nice to prove that we can support or somehow have an impact on the soil microbiome. So
So what was the failed trial? How was it planified?
Yeah. So we tested this. When was it? Sowing in 2022. So harvest this year in one variety on 2 locations. We know we should increase the number of locations. We will do, but, you know, it was the first try to see, is there something happening? So we compared it to the standard treatment, which was a fungicide and the last insecticide, and then the standard treatment plus our product. Okay. So we just coated it on top. So we have these 2 test elements, and then we took samples over time. So before sowing, at field emergence. Okay. Then a few weeks later, around the 4th leaf stage, and then before winter, so roughly around with 8 leaves.
Okay, so you were really wanting to evaluate the evolution in time also. So
exactly,
not only 1 and 2 times, but even more, to have a complete understanding of what's happening during several months.
Yeah. Even though it's a tiny amount on the seed, you know, we thought would be interesting to know, is there after 2 months still an effect, a measurable effect? That's why we have chosen the 4 points in time, and then we always took 3 samples. So on 24 samples per trial site. It was 2 locations. And when we look at the next slide, so
yes, yeah. So until now we have explained how was the trial design of what was the how we wanted to evaluate this product. Now it comes to the part of the methodology. The methodology is where we come in.
Yes.
You are designing your product, you are designing how to test it. And now for understanding how the product works is where we come. What we used for evaluating the results is that, as you said, you had several plots with several timings, and we took samples of the soil close to the plant to understand exactly around the rhizosphere, to understand what's happening around the plant and if it's affecting or not, and how much. That's the question. How much is it affecting the microbiome? Therefore, what we did, we applied the methodology of the BeCrop trial. The BeCrop trial methodology, it's for assessing and understanding the effect of agricultural products in the soil microbial functions. We can do it in different locations and during a certain period of time with several time points. In the next slide, what we see is that the base of evaluating is comparing the field before the treatment and after the treatment. And after the treatment, we can do it 2 or 3 times, but before and after, it's the key for understanding what's happening. But not only that, but even evaluating a control area with a treatment area. And that seems pretty, let's say, clear, but sometimes we have to explain it because it's important to have in mind that you need to have the benchmark, not only before and after, but also maintaining a benchmark, because the soil microbiome could change a little bit during the time, and it's important if we want to understand what's doing the product, we need to understand that. And for these samples and these results, as you can see in the next slide here, will be transformed into information that says how much these changes have occurred. For example, if for the nutrients, we will see the indicators that were improved by the product. But for example, if we have let's say a nutrition increasing in the absorption of phosphorus, in solubilization of phosphorus, we will evaluate how much was it changed, the change, if the microbial population increased by 30% or by 75 or 190%, but also if this change was statistically significant. That's the magic of doing the field trial with an organized idea and with several replicates that we can do a statistical analysis and say this change was made for 190% of increase, but we also can say that it will repeat everywhere that you use this product. And that's the amazing thing, that we can differentiate by effects, trends, and major changes, as we say. And we have to take them all into account. And well, that's what we did for understanding the product.
Yeah.
What were the results?
Yeah.
They were really good.
Yeah. But first, again, for the audience that you see, that's our whole setup on the field. So we tested many different combinations and prototypes. But you see here the C1, that's the standard treatment control check, and the C2, the plots were next to each other on both locations. And then the gray part, we have that in all of our trials. It's for invasive sampling, because we can't take plants out when we still want to harvest the plot for yield measurements. So that's why we do that. I think that's also maybe a bit special. And so it's small plots directly next to each other, so there's no crazy soil difference.
Yeah.
I think that's also really important for such a project. Otherwise, we are comparing apples and whatever. So next slide, please. And now we see the results. Yeah, I'm super happy about the results. I mean, it's also quite some work, you know. So in the beginning, you have these tiny plants, then you have to get the soil directly at the root, and it's quite some samples. So it took us really always a whole day. Then you have to send the samples in the small BioMaker samples collectors, or however you call them, pooled to Spain, to the BioMakers lab. But we managed, and yeah, here we see the results looking at phytohormone pathways. So I think we have to make clear it's not the concentration of phytohormones. Really important. It's microbes producing, for example, gibberellin or auxine. So I think keeping that in mind, then it also gets clear why it's to a certain time increased and then decreased again, because most probably in the time between the concentration will increase and then the microbial activity decreases again. So at least that's my theory.
Yeah, but it's really clear. We can see here that for the gibberellin, auxine, and cytokinin are important hormones for the crop development, crop establishment, yes, root elongation, stem elongation. So for making quicker, if the plant will need to produce these hormones to grow.
Yes.
But if the soil microbes are already giving these hormones to the plant, the plant does not need to expend resources into producing these hormones, or it can grow even faster. So you are letting more energy for the plant to grow in these initial stages. And that's a really good point. Here we see that there's, as you say, at the beginning in T1 and T2, there's a clear increase. After that, it's not so strong. But what we need is that the plant does it at the beginning. So the product here, it's working really well in both locations.
Yes,
that's
and I mean,
a success.
It's also significantly higher. I mean, you see it's up to 120% higher compared to the controller. So I also think that's quite amazing. I mean, that's what we wanted to achieve. And even looking at two different locations, so Hundlosen, it's more sandy soil. In Norden, it's a town near to Cuxhaven, so at the coastline of Germany. It's quite a heavy soil, high clay content, and I think it's also quite interesting to see a similar reaction on different soil types.
That's
as
really
I said before, we will increase the locations. I think around 10 locations, 10 different soil types and climatic regions would be even more interesting to see if it's everywhere the same. But for a start, it's really interesting.
Yeah, and that's the first conclusion that we have seen, that it improves the soil microbial communities for increasing the capacity of the plant for establish itself. But as you were explaining at the beginning, this product has even more characteristics. And as we see in the next slide, it improves also the nutrient absorption and the resistance and the vitality of the plant.
Here in Hundlosen, I mean, also between 40 to 200% increase. If you look at salicylic acid, it's 9,500%, which is insane somehow. But yeah, super cool. Salicylic acid is against stress, or it supports the plant under different stress conditions. That's also one aim of our products. So yeah, also significantly higher. Nearly all substances, or not substances, but
microbe populations producing the hormone that we want, or the substance that we want. But that's really good, because it's there. It's not only the product. It's not only helping the plant, the seed, but it's helping the environment that it creates for the seed.
Yeah.
And that's really good because you are working in both directions.
Yes, and also looking at siderophores, iron nutrition, I mean, that's for every crop super important in the early phases. It's one of the crucial micronutrients, so that's really good to see.
Yeah, that's really, really good. So it's quite a success, the evaluation here. And on the next slide, we can see the summary of the results that we have seen.
Exactly.
So here we said what was the objective of canola guard? It's improving the crop development, crop establishment, and we see it here because we have seen that the first point was about improving the germination. We have seen that there's the germination conditions have improved because we have the pheromone pathways increased, so the plant will develop better with root system, stem elongation. That's really good. And also in terms of improvement of absorption of nutrients, it doesn't matter if you are applying a certain quantity of nitrogen fertilizer if the plant is not absorbing that.
Yes.
So it makes a lot of sense that your root system develops as fast as possible in order to absorb that nitrogen as fast as possible. Therefore, you are reducing the needs of fertilizer. That's amazing. We didn't see it.
Yeah.
We didn't say it, but
yes,
to be able to have a better crop establishment allows you to even reduce the needs of fertilizer because the losses in fertilizer use are reduced.
Yeah,
that's really good.
Yeah. And also again, looking on different soil types. I mean, here the green ticks, they're on both locations significantly higher. So that's for me really important that we have on different locations similar effects. Looking at the main claims, so in the gray ones you see additional benefits on the one location or on the other. I mean, that's then your magic, or at the end of the day, we would need more locations to understand why on this location it reacts like this or that. I mean, it depends also on the start conditions, which microbes are already present, and so on. I have to mention maybe that our products, also canola guard, is free of living organisms, so we don't add additional microbes.
Okay.
So it's really just the pushing or the change in the soil microbiome based on different plant extracts and etc.
It's mostly based on the feed for
exactly
the food that you need for the microbes you want.
Yes. Yeah. And I mean, even on both locations, looking at ABBA, we see a higher resistance to stress, which is also what we wanted. And maybe we don't have it here on the slide, but over both locations compared the C1, so the standard treatment to standard treatment plus canola guard, we had an additional yield of 3%. So that also, you know, makes sense looking at the data, higher nutrient efficiency, better crop establishment. It won't always lead to a better yield. It's not a magic.
Maybe not better yield, but I was thinking that before we were discussing that one, I said that one of the opportunities for soil health, it's that with climate change, soils can be one of the key parts for tackling climate change. I was thinking that the product that you have developed and that you are selling, it's helping the plant to withstand the stress of growing in the first stages. And as we see with climate change, summers are longer.
Yes.
It means that we have less rainfall, maybe
yes.
warmer weathers, which could help or not, but we have maybe less rainfall.
Yeah.
And therefore, your product is looking to help, as we were mentioning. Agriculture will have it's adapting to climate change conditions.
Yeah.
And with products like canola guard, you can adapt having this crop.
Yeah.
In the same location with a little different condition in weather conditions, you could have the same yield. You can guarantee those same yield. Maybe not better, but you can are guaranteeing that you are getting the same yield
under difficult
conditions.
Yes, that's right. And I mean, again, it's a seed treatment, so it's one screw in a highly complex system. You know, so I think it's good for a nice start into the crop cycle. And I mean, there are more screws one could turn, you know, to improve it further, to stabilize it further, to improve the soil microbiome further. So I think, yeah, the world needs such products and needs the information and the understanding from your company. So I would say it was really a success case or just a success case.
Yeah, totally. It's a success case. We demonstrated, and you demonstrate. We demonstrated that we can demonstrate that, and you demonstrated that your product works really well. That's a key part here.
I mean, for the audience, we also had a project together on our product on cereals, growing out, where we also saw significant changes. And we will do it in our other products as well, or have a look at it. As I said, we are mainly commercial now in cereals, corn, and legumes. Partly also in vegetables, but you know, vegetables are many different species, so it takes us a while to have products for all vegetable crops. Then soon available canola gourd for oilseed rape. Then we have prototypes for sorghum, for sunflower, for sugar beet, for at the end of the day all important crops, and always the same approach because it has one foundation. So all products should have an impact on the soil microbiome. But I mean, that's just a theory. We should prove it together, I would say.
You are focused completely on, as we are focused on soil, you are focused on seeds, but not using your products for other type of treatment. You focus on seeds.
Yeah,
you're the experts on seeds.
Yes, yeah. It's not that easy to make a good formulation. So for now, we stick to the seed. But at the end of the day, you know, it would be nice to at least have a look at it, starting with the seed coating, and then, you know, maybe 2-3 times over the vegetation period to go via foliar application or something like that.
This fine tuning that you were mentioning.
Exactly. Yeah, exactly. But you know, it takes such a long time to develop a product for one crop. So I think my life is too short to develop even foliar applications. I don't know. Let's see.
Well, we finished with explaining what was the project that we did here. I think it was a great success. It was a great success. We agree on that. And well, probably there's probably many questions of people that are interested. Isn't it, Juan? Do we have many questions?
Oh, hello again. We have one question now. So please, all for the attendees, if you would like to Jan or Pedro to answer your question, please just put it all of them on the question section. To start with, I will go with one question from Dor Oppenheim. I think it's for Jan. So does the canola gourd have active dormant biology in it?
Come again?
If it has dormant biology, I think you said already that you put no biology on the products.
Yeah,
it's based on plant extracts and, let's say, inactive, not biological compounds.
No living organisms and also no spores. So I think that was the question. If there are bacterial spores or fungal spores, no.
So your product can last on the shelf for many months, or not?
Exactly. That was our aim, to have a long shelf life. I mean, sure, when you have sporulating bacteria in there, it depends on the formulation, then it's also storable for 1 to 2 years. but we made many trials with organisms added to the products, and the results were like that. Because I mean, it's still a black box down there, and if I add 1 or 2 organisms, it's a highly complex system, and down there's always a war, even though it better be between the microbes, so I can't know what will happen. So
it's complicated. Mostly if you have to store the product on the shelf.
So far, we can't sell it with a good feeling because we don't know what will happen.
Okay, so there is no more question. So we can close the webinar here, you want. Thank you so much, Jan and Pedro, because I think it was really interesting for all the audience. Well, we have one question, sorry. I'm just waiting a little bit. This is quite long. It's from Michael Kluenkan. Doing field study for nutrient use efficiency, I have made the experience that it is of utmost importance to standardize fertilizer level in the field before planting. This means soil samples should be taken before studies are started to determine what levels of fertilizers N, P, and K and their N forms are prevalent. Did you do this?
Yes.
So it's quite long, but
yeah. No, the whole how do you say that in English? The whole fertilizer regime and so on. It's like the farmer would do it on that location. It's according to the German fertilizer law, and I mean also the sample for Biome Makers was taken before weeding, but sure, the fertilizer was already there. I mean, sure, looking at oilseed rape, there's also a spring fertilization, but we didn't look at springtime. And in Germany, it's anyway forbidden to put NPK, I think after the 1st of October. So I think there's no error coming from nutrients, or you know that the results are, and we always compare the control to the treatment. So
exactly, something that we did here doing the BeCrop trial, as we are comparing the treated area before and after, but with a control area, we have the image of the control area that has not been treated before and after. Therefore, we have already the changes and the, let's say, the baseline scenario for understanding what's making the product. Of course, there could be, if there's really high levels of nitrogen, NPK, the population would change. But for we can correlate that with leaving that information aside. Of course, with really high levels, it would be more difficult to say that it's completely representative. But doing this type of analysis and these comparisons will reduce the impact of that. So,
but we also start now looking especially on oilseed rape on nutrient efficiency or efficacy trials that are quite complex field trials. So if the person wants to have more information, he or she can get into contact. I have also all the data looking at those 2 locations where we did the trial, all the fertilizers given, plant protection applied, and so on.
Great. We have another question now. So Major Tondorf Lucas, sorry if I misspelled something, but the question is, in case of the trial, is there a positive ROI?
Regarding the project. Yeah, that's a really good question. Is the cost of the trial that we had, let's say, several thousand euros, or depending on the size of the trial, is the ROI, the return on investment, positive or not?
We don't sell the product yet.
that was going to be my answer.
That's quite an investment, but for us it's really important to understand, and also, you know, for our customers. I mean, if we can really prove, and I mean that's a proper proof when you show an increase of up to 400% or whatever. So at the end of the day, I think yes, it makes sense also on a economical perspective. Sure, you know, I'm a scientist. I always love stuff like this. I could spend and waste a lot of money. Maybe I'm also the wrong guy to answer this question.
We should ask Jakob for that. Coming back to that question and what other customers have told us, until now, there's more than 150% of the average of what some customers shared with us in the same industry. Regarding the sales, and in two parts, there's a return on investment. On one hand, on being able to differentiate the product better from the competition. If you can say better that I'm increasing this and this and this in these rates with a certain statistical security, of course, can differentiate the product from the competition. So it helps to increase sales, not only by saying that you have a product that it's tested, but also because for the sales teams on the ground, it's easier to sell a product. You're providing tools for the sales team to sell the product better. But not only that, here today, what we are discussing is about the product development. Being able to gather this information makes that the product development phases are faster. Therefore, there's a cost of reduction in the development process of the product, of the treatment. So regarding those understandings, there's customers that have shared with us that the return on investment is more than 150, 170%, I think they said in average. So that's a quite important question, of course. But it's an investment, as you say.
I never thought of it. Because I'm just a scientist.
Okay, so there is no more question. So now we are going to close the webinar here. In case there is any more question, just we will send you the webinar recording after to all the attendees, all the registered ones. So you can just reply to us, to Biomaker, and we will send you the question to Jan or to other member of the team. Thank you so much, Jan and Pedro, to being online and be together over there. It was really, really interesting. I hope to see you in future webinar as well. And also just another reminder here for all the people who are attending this webinar. Biomaker is going to be on AgriTechnica, so on the pavilion 11, I think it's C45. So if you are around, you can go and meet Pedro, do any you can make any question over there and meet us in real life. So thank you so much, both of you. Have a lovely afternoon, and thank you so much to all the people who attended this webinar. Thank you.
Thank you very much.
Thank you.
Bye.
Bye.
Thank you. Bye-bye.
Really good.